This video will cover section 5.4, sum and difference formulas. The objective for this section will be to use the sum and difference formulas to evaluate trigonometric functions, verify identities, and solve trigonometric equations. So I know that identities are not your favorite, but guess what? We're going to add more to that list of identities. The good news is that you are able to use your, to make a formula sheet and use your notes while you do your homework and quizzes. So even if I was giving you a test in a regular class in person, I will I've always let my students have these formulas handy within a formula sheet. The reason for that is that you could see how they are very close to each other. Well, I'm gonna read them from top to bottom. So the first one represents the sine of two angles. And so the sine of the sum of two angles. And so that one could be expanded into the product of two trigonometric functions. So for example, we will take the product of sine of the first angle, which is u. So we have sine u, and then times the cosine of the other angle, which is angle v. So we have sine u times cosine v. Now, because this is a sum of two angles, here you will also see a positive sign. I'm going to highlight the sign so you get the signs of the sum. So it's a plus and another plus. Okay. And you can see here they are different because you take the sine of the first angle times the cosine of the second angle, and then cosine of the first angle times the sine of the second angle. Now, when we move on to the next one, which is the sine of the difference of two angles. And here, this is the difference because they are subtracting the two angles here. They are subtracting. And so the formula, you could see here, it will have a negative sign as well. And the product is the same, the exact same as the previous formula. So let's go ahead and just refer to them as 1 and 2. Okay, so that's the how they're similar and how they're different. Now, when we move to number 3, which is the cosine of the sum of two angles, so we're adding two angles again. And so the formula in this case, if you notice, it's going to be a subtraction, a difference of the product of two trigonometric expressions. So when we are talking about sine and cosine, the positive sign, it's the same, the negative is the same. But when we're talking about the cosine of the sum of two angles, the sign here will be the opposite. So you could see that with number 4, the next formula, we're going to have a negative here. So it's the cosine of the difference of two angles. And so we expand it as the product of two trigonometric expressions. Well, actually, as the sum of the product of two trigonometric expressions. And once again, for the 2 of cosine, we have opposite signs. So we have negative and then positive here. Positive and negative here. So that's something to remember as well. And the products, they're going to be the product between cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. For the cosine of the difference of two angles, we have the product of cosine of the first angle, cosine of second angle, plus sine of first angle times sine of second angle. So you could see clearly that the products here are the same, and so are the products with the sum and difference of sine. Okay, so as you can see, the formulas are very close to each other, so that's why I was saying, you know, having these formulas handy will make things a lot easier. So the next two that we have here, so let's label them as 5 and 6. Number 5 is the tangent of the sum, the addition of two angles. And then number 6 is the tangent of the difference of two angles. And as you can see here, we have ratios. So on the numerator, we have the addition of the two tangents. So tangent of the first angle plus tangent of the second angle. On the other formula, number 6, we have on the numerator, we have the difference of the tangent of the first angle minus the tangent of the second angle. Then for the denominator, they are almost the same, except that they have opposite signs uh, in the denominator. So we have here a minus, and on number 6, formula number 6, we do have a plus. So that is the difference with those two formulas. So as you can see, it is kind of easy to make a mistake. So make sure you do have your formula sheet close to you when you do your homework, when you take the quiz, and when you take your exam. Okay. Now, for example 1, we're going to show how the sum and difference formulas can enable you to find exact values of trigonometric functions involving sums or differences of special angles. So, to refresh your mind, the special angles are those that have that we have been looking into from the beginning of chapter 4. So that will be 30, 45, 60 in degrees, 90, of course, 180, and so on. In radians, it will be like pi over 6, pi over 4, pi over 3, pi over 2, and this is pi. And then, of course, you know, we went over reference angles and all of that stuff. So we do have those special angles. So for example, if we had sine of pi over 12, and I know you might not like fractions that much, but let's do something. Let's do this problem with degrees first, and then we will do it with radians and see how you feel about it. So remember to convert from radians to degrees. We will have to multiply by the unit conversion factor 180 degrees divided by pi. And I chose that one because here pi will cancel with pi. So then I'm going to get from here 180 degrees. Also the units radians cancel out. Divided by 12. And so 180 degrees divided by 12. So I'm going to first divide by half. So I'm going to have, or divided by 2, I'm going to have 90 degrees on top and 6 on the bottom. So let's see, we could divide 90 by 3 and we will get 30 degrees. And if we divide 6 by 3, we will get 2. And so 30 divided by 2 happens to be 15 degrees. So I just wanted you to, I wanted for you to get an idea of what we're going to be doing. So if this question was find the sine of 15 degrees. What I would try to do is use some of those special angles. So I could use, for example, 60 degrees, and I could also use 45, because if I subtract 60 minus 45, I will get the same as 15. So these two expressions are the same. And so that's what we were trying to do, to use the ones that we already know to find the solution. So this problem will continue this way. The formula for, if we look at the sine of the difference of two angles, that will be formula number 2. So it's going to be this one that I'm pointing at with my mouse. So that's what we have. I'm going to write it down that way. So we're going to have sine of the first angle, so sine of 60, times the cosine of the second angle, which is 45. And then we're going to have a minus, and then the next one will be cosine of the first angle, which is, first angle is 60, and then times the sine of the second angle, which is 45. And with that, we will be able to find the sine of 15. Now, doing this by with radians, it might be a little confusing because of the fraction. So if you look at your denominator, which is 12, if we look at the denominators that we have here for the special angles, we could recognize that some of those denominators are factors of 12. So 12 could be divided by 2, by 3, by 4, and also by 6. So if we think of it that way, we could use two of those special angles to give us pi over 12. So in this case, we take pi over 4 and pi over 3. We know we're going to subtract one from the other. And because I did it in degrees, we kind of have an idea of it. But if you don't have it in degrees, you could think of it this way. Which one is bigger, pi over 3 or pi over 4? So remember, the smaller the denominator, the bigger the fraction. So pi over 3 is bigger. And so it makes sense that we say pi over 3, and then from there we subtract the pi over 4. So to compute this, we need to have both fractions with the same denominator. And so for that to be a 12 for the first fraction, which is has a denominator of 3, we need for it to turn into a 12. So what do? We have to multiply both top and bottom by 3. I'm sorry, not by 3, but by 4. And we do that because 3 times 4 will give us this 12 that we have here. So if we multiply the numerators, we will have 4 pi. Now for the second fraction, also we wanted to have a 12 and we have a 4. So the only way we could get a 12 from 4 is by multiplying it by 3. And whatever we do to the bottom, we must do to the top. So here, 4 times 3 is 12. And then pi times 3 will be 3 pi. Now from here, now that they have the same denominators, we can just subtract the numerators, and that will give us 4 pi minus 3 pi. That will be 1 pi over 12. So that means that the numbers or the angle measurements that we chose, they work. They will both, when we subtract them, they will both, not both, but after subtracting one from the other, we will get pi over 12, which is what we needed. So now going back to the equation, now that we know why we chose pi over 3 and pi over 4, as you could see here, pi over 3 minus pi over 4. So now that we know that, I'm going to go ahead and use the formula. Just write it down for you. So that one is going to be sine of the first angle times the cosine of the second angle, and then minus the cosine of the first angle times the sine of the second angle. And that's the formula. We have a minus here, so we will also have a minus there. And that, I believe, is formula number 2. So as you could see here, the first angle was u, and our problem, that was pi over 3. So you could see here sine of pi over 3, and then here cosine of pi over 3 of the first angle. And then the other product will be cosine of the second angle. Second angle here is the pi over 4. So we have cosine of pi over 4 and then sine of pi over 4. Just like on the formula, we will have cosine of v and sine v. So we know what those actual values are. And now what I'm going to do is actually replace the sine of pi over 3 with the trigonometric ratio. And that will be the square root of 3 over 2. At this point, I don't need to include the word sine because what I'm saying is that sine of pi over 3 is the square root of 3 over 2. So I'm replacing the left with the right side. Now the cosine of pi over 4 is going to be the square root of 2 over 2 minus cosine of pi over 3, which is 1/2. And times the sine of pi over 4, which is also square root of 2 over 2. And now what we do is we multiply. So we're going to multiply straight across, so numerator with numerator. Square root of 3 times the square root of 2 is going to be the square root of 6. And then 2 times 2 is equal to 4. Then minus, and then we multiply straight across. 1 times square root of 2 is just the square root of 2. And then 2 times 2 is equal to 4. Because the two fractions have the same denominator, we could also write them under one fraction. Like that. So that will be also be a valid answer for the exact answer. The exact answer or the exact solution. That whole thing will be the exact answer. Now, if your assignment on WebAssign is asking you to find an approximation, of course, you could enter that on the calculator and you will get an approximation. Or you could even, if you want to check your work, you could approximate this one, the one that we found with the formula, and then you can enter the expression that you see here on the calculator and then see if both of them will give you the same approximation that we see here, 0.259. Like we said at the beginning, we could also, well, actually I said we are going to add more formulas to our identities. And so in this case, we do have an identity on this side, on the left side, and it is in the form of an equation, because remember, that's what an identity is. And the thing that makes it be an identity is that it is true. The equation will be true for any value of x. And also, this is one of the cofunction identities that we have. And so we're going to prove that it is true by using the new formula that we used, that we learned at the beginning of the section, and that is the cosine of the difference of two angles. Those two angles are pi over 2 and x. So on your slide, I believe it's slide number 2, we do have that formula, and I'm just going to go to it. It will be formula number 4, the one that you see here. So that is the formula we're going to use, and let's write it down first on this line. So it's going to be the cosine of the first angle, which is u, times the cosine of the second angle, which is v. So you could see that, cosine u, cosine v. And then we're going to have a plus in between. And then we will have sine of the first angle, which is u, times the sine of the second angle, which is v. Now, if we do the same substitution, but instead of using angles u and v, we use the angles pi over 2 for our first angle, and then x for our second angle. So you could see the formula here is the substitution has been made already. So it is the cosine of the first angle times the cosine of the second angle. Then we have a plus, and then we have sine of the first angle, and then times sine of the second angle. So what we do after is we're going to replace the whole expression. So for the cosine of pi over 2, we are going to replace that, and just so you know what we're talking about, pi over 2 is up here. And so if from the unit circle, you know the coordinates there are going to be 0, 1. So let's see. Cosine will be that coordinate, and the first one, and then the second coordinate represents sine of pi over 2. So the cosine of pi over 2 is equal to 0. So we just replace that expression with the number 0. Then cosine x would still be cosine x, just like that. Then we have the plus sign, and now we need the sine of pi over 2, which is going to be the number 1. And then here we have sine x. So if we carry out the multiplication, 0 times cosine x is just going to give us 0. And then here 1 times sine x is going to be sine x. And so 0 plus sine x is equal to sine x. So remember, once you start working on one side of the identity and you're able to make it look like the other side, that means that you have proved the identity. And so we're done with that. Using the sum and difference formulas can be used to rewrite expressions, such as the two that we have here, the sine of theta plus n pi over 2, and the cosine of theta plus n pi over 2, where n is an integer like we've been seeing. And what happens there, you get expressions involving only sine or cosine or their reciprocals. Those formulas are called the reduction formulas, and I just did a Google search for reduction formulas in trigonometry. And so based on those, I found one of the images, this one here, and I thought it was a very interesting table. So as you can see here, if you have the sine of pi over 2 minus alpha, that will be equal to cosine of alpha. But if you have something like sine of pi minus alpha, that will reduce to just sine of alpha. And you could see other examples here with 3 pi over 2 minus the other angle or plus the other angle, or also with 2 pi and minus and plus. And you could see for sine, cosine, tangent, and cotangent. So I don't know if this will be of any use to you in the future, but I thought it was pretty cool to have it. So I'm going to go back to our notes. And so remember, those are reduction formulas. And we're going to go ahead and work with the next example. It's 7. So it involves solving trigonometric equations. So remember in section 5.3, that was about solving trigonometric equations, but we were doing that with angles that were only well, actually we did do some with double angles or 3 times theta or something like that. So now the difference with this new section is that we're going to add some equations, and those will involve the sum of 2 angles, the sine of the sum or the addition of 2 angles, and also the sine of the difference of two angles. And so when we start solving for the equation, our first step is going to be to use our formulas to simplify those two expressions. And so that will be, for the very first one, if you look at formula number 1, and for the second one, it will be formula 2 from the second slide. Now, also notice how here they're asking us to find the solution, only not the general solution, but only from 0 to 2 pi. So if we substitute the first expression here, we will have sine of the first angle times cosine of the second angle, then plus cosine of the first angle times sine of the second angle. So all of this is replacing this first expression, the sine of x plus pi over 4. Now, the positive sign that we have here is just the one here that comes from the equation. Now we're going to use the second formula to replace the second expression here, or term, and it will be sine of the first angle, so sine of x times cosine of the second angle, pi over 4. And then if this is negative, you can confirm by looking at your formula sheet, this should be negative as well. So we have the cosine of the first angle times the sine of the second angle. And that's what we did here. So we just replace that. We replace this expression with the one inside the rectangle, the blue rectangle. And here the number negative equals -1, we just simply transfer it down. Now let's see what could we replace, and or what could we do if there are any terms that we could perhaps combine. So if you look at, and I'm just going to rewrite them so you know where they're coming from. So we have here sine of x cosine of pi over 4. And then we have the exact same term here. So it's like I have one of those plus another one of those. So now I have, well, let me just write it and then we will combine them. Sine x cosine of pi over 4. Now you can notice that the cosine x, and let me highlight it, cosine x sine of pi over 4 has a positive sign here. And then we have the same expression, but now with a negative sign. And so that will be like having opposite numbers, like 2 minus 2, 3 minus 3. So we know that equals to 0, or we say they do cancel out. So then we're just left with that and that. So if we add those two, we are going to get 2 times the sine x cosine of pi over 4, because we have two of those, is equal to -1, and that is what we have here. So what I'm going to do is replace what we know, and we know that cosine of pi over 4 is the ratio square root of 2 over 2, and that is equal to -1. Now what's going to happen is that the 2 sine x is multiplying to the square root of 2 over 2. And so the 2 here divided by the 2 here is equal to 1. So we say they cancel out. In fact, let's do that on the next step. So from here, the same equation that we have here, it's what we have written here. So then if we cancel the 2 and the 2, we are just left with sine x times the square root of 2 equals -1. So what the square root of 2 is doing to sine x is multiplying. So if we take that across the other side, it will be doing the inverse operation, which will be division. So now we have the square root of 2 dividing the -1 on the right side. And just so that you recognize what we're talking about, if we rationalize the denominator here, so that we don't have an irrational number on the denominator, we multiply across, so we will have negative square root of 2 over, and here it's like we're doing squaring the 2 inside the square root, so that will cancel each other out. So we have negative square root of 2 over 2. Now, since the question required us to find the solutions in the interval from 0 to 2 pi, I'm going to go ahead and draw our unit circle. And we know that for sine to be negative, it has to be in quadrants 3 and 4, because that's where the y values are negative. And we know that that will be like something similar to pi over 4, except that at that point, both sine and cosine are positive. So it's going to be a multiple of pi over 4. And if you do have your unit circle, you could see clearly that it will occur here. And that is pi over 4 past pi. So it's like pi plus pi over 4. That will be 4 pi over 4 plus pi over 4. And so that happens to be at 5 pi over 4. The other one, the other angle, and actually it goes like that. The other angle, it will be in quadrant 4. And that is going to be an angle that starts here, positive x, counterclockwise direction, and we land in, the terminal side lands in quadrant 4, and that is actually the angle 2 pi minus pi over 4. And so that will be 8 pi over 4 minus pi over 4. So that is equal to 7 pi over 4. So that will be that angle, 7 pi over 4. If you were to enter this on the calculator, as something like sine inverse of the negative square root of 2 over 2, the calculator will tell you that the answer is negative pi over 4. Why? Because sine inverse is defined in quadrants 1 and 4 for the interval, well, including, so bracket negative pi over 2 to pi over 2. And so if you enter that on the calculator, that's why the calculator will tell you, if you enter this expression, the calculator will return negative pi over 4, or the approximation of it. However, the question is asking us to find the solutions in the interval 0 to 2 pi. So instead of using negative pi over 4, we have to think what positive angles that are greater than 0 and less than 2 pi will give us sine is equal to negative square root of 2 over 2. And so that's what we have here, the solutions, 5 pi over 4 and 7 pi over 4. And so another reason why you need to learn the unit circle and how to manipulate it. So this is the end of the video. This is the shortest video I ever made. So I hope you will watch it and do your homework.